Presenting functions by turning them into, or as a power series today, okay? So they're going to give us a function, and we're going to try to turn it into a power series, okay? So is there a place for you to write that down? Do we see that? Is there a spot or no? Okay, put that out in the left-hand column, okay? So write that in the left-hand column. So what we're going to do today, okay, is we're going to try to get our function in this format so that we can read a sub 1 and we can read r, okay? So what we're looking at is to have 1 minus something in the bottom, okay? And there's going to be a lot of different algebra that we use to create that, okay? Because we might not be set up perfectly like that every time, okay? And then we're going to, at the end of the problem, we're going to plop it into this format, okay? So looking at that problem, again, I want to create a sub 1, 1 minus r. I don't have a minus there, right? So I'm going to create it with a minus. So I would have to put in a double negative to make it minus. Everybody okay with that? So all I'm trying to do is recreate something that looks like this. Okay? So what that means, we're listening, I hope. Okay? Is we know that a sub 1 times r, was it r to the n or r to the n minus r to the n? Okay? So what we're going to do then is now we're going to be able to write our power series. So n equals 0 to infinity. What's our a sub 1 according to this? 1. What is our r? Negative x to the n. That's it. Okay, that's it. Okay, now that's what we're going to focus on during the lesson. Okay, shh, I need you to listen. All right, they may add extra instructions in the book. Okay, so you might see and determine the interval of convergence. Okay, centered at C. Okay, this is what we did the last couple of days. I'm not going to go over that again. Okay, so this is do the ratio test, find the interval, and test the endpoints. Okay, so if that comes up in the instructions, you got to refer to what we did yesterday and the day before. Okay, all I'm going to worry about is focusing on setting up that power series. Okay, all right. So let's set up this power series. Again, I want that format of a sub 1 over 1 minus r to begin with. Okay, is it already like that? Yeah. Yep, so there isn't much to do on this one, right? So we've got the sum as n equals 0 to infinity. What's your a sub 1? 1. X is your r. X cubed is your r to the what power? N. That is not likely what a multiple choice question would look like. Okay, likely they'd put these together. So again, I'm going to baby step you into this making this algebra kind of fancy. So really, they would probably show x to the 3n, and that would be what the answer looks like multiple choice. Okay. All right. Let's take a look at the next one. What do I have to add in to make this a 1 minus? A double negative. Okay. So that's what we would make it look like with the negative in there. So we've got the sum as n equals 0 to infinity. What's your a sub 1? 1. What's your ratio? X squared to the what power? N. Now again, that's probably not going to be what they write down for their multiple choice. So let's play with that a little bit. I'd probably distribute that in. Okay, so you're probably going to see something more along these lines. Negative 9 to the n and x to the 2n.
Okay, where would they write it like that?
Multiple choice.
What multiple choice? The AP test?
On the AP test, yeah. Okay. Likely, and if you're looking at your answer book in the book, it's going to be written more like this. Okay? So I want to make sure you can get there. If it was free response, obviously we would stop on the previous line. Okay? All right. Let's look at 4. Okay, so 4 has a little bit more to it. Okay. We don't have a +1 anywhere, do we? So I need to create the +1. So here's how I manipulate it to create the +1. What could I divide this by to get 1? 2. That's where the +1 is going to come out of, right? So if I divide that by 2, I have to divide every single thing by 2. Okay, because I'm trying to create the +1 now. What is 4 divided by 2? 2. And I'm going to rearrange this order to get it in the right order. We would have 2 over 2 is 1, and then I'd end up with x over 2. Right now it's a plus. How do I create a minus? The double negative, right? Okay. Now we're ready to read and put it into our power series. So what is your first term? 2. What's your ratio?
1/2. Negative 1/2 x.
Negative x over 2 to the n power. Okay? Again, we're going to do some fancy algebra. I think the algebra is probably worse than the calculus today. Okay, the calculus is writing it into this step, right? That's the power series. All right, so we could distribute that over the top of this. Again, don't go to college and say that's distributing, because that's not really distributing. But I don't know. It's probably a power of a quotient property or something along those lines. I don't know what it's really called. I can never remember it. All right, so this is really, I'm doing too big of a parentheses. Okay, so it's really negative x to the n over 2 to the n, right? And then this technically has an n 2 to the first on it. Can't I get those two bases together? Yeah, so when we have division like that, what do we do with the exponents?
Negative. Or add them.
We subtract them, right? Okay, so my final answer on that one would be the sum is n equals 0 to infinity of 2 to the 1 minus n negative x to the n power.
What?
We okay? What's wrong?
Where'd you get the 1 minus 1?
Okay, let me explain it again. Everybody ready? Because I'm going to explain how I got this little piece here again. Okay? So, when we are dividing, we are allowed to subtract our exponents as long as the base is the same. So my base was 2, so I subtracted my exponents. So my top exponent stayed positive, my bottom exponent I subtracted, so that's where the minus n came from. We okay, Joaquin? No? The property is if I just had this, so let's say I had, let's not do 2. Let's say I've got x cubed over x, right? Don't I have to, in order to simplify that, don't I technically subtract the exponents? It's the same thing.
Oh,
Okay? We just use variables.
so the n just goes to the top.
Yep.
minus n, and then just
Yep.
2 at the bottom.
Yeah.
Can you go back to example 3 really quick?
Yep. Everybody good with example 4 before I flip back? Okay, Cody wants me to go back there.
Okay.
We got it?
Yeah, thanks.
Okay. Alright, let's look at example 5. Notice there is no 1 this time, right? So in order, I have to get the 1 minus part in there. Okay, so I have to create it. So part of our job is to have to, sometimes we have to create the function that we need. Okay? Oh, and I missed something on this. Sometimes it'll tell you where it needs to be centered. Okay? So this one I probably should have had the words centered at 1 in there. So if I'm centered at 1, don't I really need an x minus 1 in the bottom? Yeah, because I need an x minus c going on somewhere, right? So if I'm going to do that, don't I really need, or if I'm going to put in a minus 1, don't I also need to put in a plus 1? Because I can't, I have to make 0, right? So if I add 1, I subtract 1. How do I make this, though, so it is, what operation do I really need in there?
Division.
No. It has to be a sub 1 over 1 minus r.
Oh,
I need subtraction. So in order to add that negative in there, what do I need to do to these two signs? Change them. Okay, so if I'm going to put a negative in here, I also need to make this negative and switch that back to positive. Okay, let me explain one more time because I want to make sure we got that. Okay? So, I missed having the instruction in there that said centered at 1. Centered at 1 means I need an x minus 1 somewhere to be centered there, right? So really this denominator needs to be x minus 1. If I'm going to put a minus 1 in, I need to add a positive 1. Okay? Then I also need to set it up so that it is 1 minus the ratio. So when I put that minus in, it's going to flip the signs on these. Okay? All right, now let's write our power series. N equals 0 to infinity. What's your a sub 1? 1, good. The ratio is that whole funky binomial there, right? So negative x plus 1 to the what power? To the n power. Okay. There is something funky that might happen with this. That's a good answer. But could I take we don't like to see that negative in front of the x. So they could take out a negative 1 to the n and then swap the signs back. You see what happened? Basically I factored out a negative 1. You have to raise it to the n power. Yes.
What if it's centered at something other than 1?
So if it was centered at 2, you would do 2 and 2. Right?
But then you wouldn't get the 2 minus.
You'd have to go back in and divide everything by 2. Right? So if it's something other than 1, you're going to have to, but whatever it's centered at is what you would put in these two spots. Okay? All right. Let's try another one. We're just going to kind of keep upping the complexity. All right? So, it looks like I'm close, right? Except that there's an x in the top. We don't really want an x as an a sub 1. So, we're going to kind of move that around a little bit. So, let's see what we can do with this. So, I'm going to split it up a little bit. I'm going to say that this is x times 1 over... If I started... writing that in the right order, wouldn't I do 1... It would be plus the 4x. How do I make it a minus 4x? The double negative. So I'm going to do that all in one step. So let's think about what I did. I took out an x, right? I just took that x off to the top. We're going to multiply it by this. Okay. I reversed the order. So I put the 1 in front. So I got my 1 up front. And then in order, that would have been a positive 4x. So to get the minus out of it, we had to do the double negative. Is it set up in the right format to do a power series? Now the power series is only going to be on that part. So I have to drop that x down. Actually, it's not equals. So drop the x in front of the power series. N equals 0 to infinity. What's your a sub 1?
1.
Do I really need to write it? No. Okay, what's your ratio? Negative 4x to the n. Is that likely what's going to what your answer is going to look like? No. Okay, so I'm going to distribute that in, and there's going to be some other fancy algebra here in a second. Okay, so the sum as n equals 0 to infinity of negative 4 to the n, x to the n. Do you see how we have two x's?
You have 2 n's. 2 x's?
Yeah, I distributed the n over both of them. Okay? Right? This n came in and was the exponent on both of them.
But that's only 1 exponent.
Okay?
You just made 1 exponent to 2 exponents.
Yes. You'll see why in a second. Okay? All right. So, see how we have an exponent of 1 on there? They're going to probably put these bases back together. So, it's technically under multiplication. So, when we multiply, what do we do with our exponents? Add. So, we're going to do the sum as n equals 0 to infinity of negative 4 to the n, x to the n plus 1. So, what you want your similar bases, your like bases, to only be there once and have one exponent. Okay? All right, we good with that one? All right, let's look at example 7. So I'm going to put a couple of things together in this one. Okay? All right. I am going to... Slightly different technique. Last time we divided by 1. This time I'm going to do it a little differently. So So I want to get that x out of the top to begin with. So I'm going to do actually quite a bit of algebra here. I'm going to pull the x out, just like we did on the last one. And I've got 1 over 9 plus x squared. All right. There are multiple ways to get it. One technique is we could divide everything by 9. Okay? And that would get us the 1 there. Another thing we could do just with the denominator is factor out a 9. So let's try that this time. So I'm showing you another way to do the same, something similar that we did before. So when I take 9 out of this, don't I get 1/9 left behind? Okay, remember factoring is dividing, right?
Yeah.
So if I take a 9 out of this one, I'm left with a 1. If I take a 9 out of this one, I'm basically dividing it by 9, I'm left with a 1/9. Because if I distributed that 9 back in, I would get 9 over 9, which is 1. Okay? All right. I'd like to also... So this is now just a coefficient, isn't it? Couldn't I throw that coefficient out with this x? So you get x over 9, 1 over 1. I have to create a minus in here. How do we do the create the minus? Double negative. So minus x squared. I'm going to go ahead and put it over 9. All right. I'm going to go up to the top here and create my power series now. So the sum as n equals 0 to infinity. I have to keep that x over 9 out front. That is times, this is the part that's going to become the power series. Okay? So, what's your a sub 1? 1. Not going to write it down. Okay? But my r is this negative x squared over 9 to the n power. Okay? I'm going to distribute that in. I'm going to do one extra little thing on my distribution so you see it. I don't like that negative right there, right? So the way we get rid of that, and it ends up creating it's what we do to create the alternating, right? I'm going to do negative 1 to the n, x to the 2n over 9 to the n. So it's like I had the negative 1 in there and I distributed the n over that as well. Typically, when we see a negative, it's going to get isolated out that way. All right. Could I put these two things back in? Well, you're not going to see them left out, right? So we are multiplying, what do we have to do to our exponents?
Add 1.
Add them. So we're basically going to add 1 to both of those, and we've got it. So n equals 0 to infinity, negative 1 to the n, x to the 2n plus 1 over 9 to the n plus 1. All right. We go with 7. All right. I think that there's something... I think all of these should have probably been centered somewhere. This one was at 0. Would have been at 0. I'm going to tell you that this one is centered at negative 2. Okay. So I'm going to do some work off to the side to figure out what I'm going to replace my denominator with. Okay. So right now my denominator is 5 minus x, right? But for the x, I really need to get in there x plus 2, because remember we reverse our sign. So I need to figure out what I have to add or subtract here to get this. Really, isn't that distribute the negative? So what would I have to put in there in order to get a 5? What's 3 minus 2?
Oh, 7.
I'd have to put in a 7. Okay, so let me explain how I got that in. Everybody write it down. Okay, so there's a piece missing. I should have probably told you it's centered at negative 2. So remember, when it's centered at something, you have to do x minus c. So that double negative is going to go positive. Okay? So I have to take this 5 minus x, and I have to get in there the x plus 2. Well, I know it's got to be minus the x plus 2, because it has to be 1 minus something, okay? Or actually, there's a minus already in there. So I distributed that in, and then I had to fill in the blank. I had to figure out what I would have to put in there to get the 5. So we know that 7 minus 2 is 5. So I'm going to take this and replace it down here. Okay? Actually, I'm going to take and put this version of it down there before I distribute in. So we have 4 over 7 minus x plus 2. Now, there's no good way to factor out on that one. So what was the technique we used to get this to be a 1? Let's divide everything by 7. Okay? Including the numerator. Alright, so we're going to rearrange it. So we've got 4/7 over 1 minus x plus 2 over 7. Alright, my sum, so I'm writing my power series now, is n equals 0 to infinity. What's your a sub 1? 4/7, good. And then my r is this whole thing here, right? So x plus 2 over 7 to the n power. I need to distribute that n in. So n equals 0 to infinity of 4/7 x plus 2 to the n over 7 to the n. Alright, I'm multiplying. I have bases that are the same. What do we do with the exponents? Add them. Good. So I've got my final line would be sum is n equals 0 to infinity of 4 times x plus 2 to the n over 7 to the n plus 1. Okay. We got it? Not yet? Okay, I'll wait. Okay, I'm going to tell you on the next one that that we didn't add in there that it's going to be centered at 2. So your center is going to be 2. Okay, so I'm going to play with that center for a minute. If center is going to be at 2, that means I need to have x minus 2 in there, right? So that x minus 2 would eventually replace that x, wouldn't it? What's in front of the x? 2. So I need to play with the fact that there's a 2 in front. If I distribute that 2 in, I'd have 2x minus 4. But I have to get that equal to... I want to replace this whole thing into the 2x minus 1. So what am I going to have to add or subtract? I've got the 2x part. I need to turn that negative 4 into a negative 1. So what am I going to have to put in the blank? Good. So really what I'm adding back in, I want this version of it though. Okay, I'm going to do 3 plus the 2 times 2 minus x. Alright, so I've got 3 over 3 plus 2 times x minus 2 is what I'm subbing in for the 2x minus 1. Alright. I want this to be equal to what number?
Can you just write 5?
Why would I write 5?
Because 3 plus 2 equals 5.
It's 3 plus 2x. Can't put a 3 and a 2 together. Huh? But this here is the, please excuse my dear Aunt Sally says I have to act my parentheses before I do addition subtraction. Okay? And if I tried to make it 5, I would not get the 2x plus 1 back. Okay? Alright. So, in order to turn this into a 1, what do we need to do?
Divide by something.
Divide by what? 3. So I'm going to divide every single term by 3.
Lefty.
You're awesome. Actually, we're going to just stick it in the cooler. Yeah, because I'm going to have the half of 5th period go put ice in it. So you're awesome. Thank
Got
you.
4.
Huh?
Got 4.
Got 4 what?
Didn't tell me how many.
Oh, 1 was plenty. Thank you.
I'll put the others in the fridge.
Yeah, put the others in the fridge. I don't think we'll go. Actually, put 3 of them in the fridge because the forks can just go there. You want to put 3 of them in the fridge. We won't go through more than 1 today, if that. Oh, you did awesome. We'll be good for like the
Good
rest
job,
of the
Mr.
season.
Lepis.
Yeah, good job.
More prizes.
Yeah, thank you.
I should have sent you with my bag. So you
Only
didn't have to
3
buy
of
a
you?
bag.
Seriously? Better. Yeah, I paid 10 cents.
I'm sorry. I should have sent you with my green bags.
Cost me 10 cents.
Oh no, 10 cents.
It's okay, I can't wait to throw it in the landfill.
Yeah, throw it in
In
the
another
landfill.
plastic bag.
Yeah.
You guys learned some calc. Figure out how to save the planet.
Are you going to put those out in that one out there?
I'm gonna put it in this one in the.
Yeah, sounds good. Thank you.
You're welcome.
All right. So we've got 3 divided by 3 is what? 1. 1 plus, and then I'm going to put this all kind of inside. So, ooh, what do we still have to create?
Minus.
A negative, right? So we got to do a double negative there. So minus 2/3 x minus 2. So that whole thing becomes the r. It's kind of icky, but it becomes the r. All right, in order to have enough space, I'm going to do the rest of my work over here in this box. All right, so I'm now going to create my power series. So n equals 1 to infinity. What's your a sub 1? 1. I'm not going to write it down. I'm just going to write my r. So it's negative 2/3 times x minus 2, the whole thing to the n power. Now, our book or multiple choice is going to write it fancier than that. They're going to distribute that n in. So they would write it as negative 2 to the n, x minus 2 to the n over 3 to the n. All right, I actually think we probably had more in the notes than you have problems in the homework.
I think so. So 5? No, 1.
There's 5, 6, 7, 8 problems in the homework.
Whoa, 1 less.
Okay, 1 less. Well, I probably made the first one really easy to get the idea, right? Okay, so I'm going to let you guys get started on the assignment. All right. Our goal, I did remember I laid out the calendar. It's there in Haiku. We should be done with chapter 9 teaching pieces of it by Friday. Okay. And then, yeah, that's yay. That means next week we're going to kind of go into review mode. And then I'm going to give you the 3 days we have in class to kind of review together. We'll do some review activities. And then on Friday, we will take the test. Okay. And I'm working on, last night everybody said they wanted Tuesday night.
What? 2 days?
If you want me here for tutoring next week. So start thinking about that, and we'll kind of try to decide maybe Friday. Okay. Thursday night is not good for me. So I could possibly get away with Tuesday or Wednesday. Okay, we'll see. Although there's a board meeting next week, so if I come Tuesday, I'll probably have to bring the boys with me. Yeah. Go ahead. Yeah. What do you want to do?
CSF.
CSF?
Psychological thing we put first.
Yeah,
so
go
I have
ahead.
to check.
Yeah.